Hello everyone, I'm Marta Halbeck. I'm going to be the chair of the webinar today. Just take note that the webinar is being recorded, and if you do have any questions for the speaker, you can post your questions in the text box of the question panel. So I would like to take this opportunity to welcome all of you to the IEEE Computational Intelligence Society webinar, where Professor Anna Wilbeck is going to talk about the explainability challenge in descriptive analytics. Do we understand the data? Now, Anna is currently a professor in data fusion and intelligent interaction in the Department of Advanced Computing Sciences of Maastricht University in the Netherlands. Currently, she's also chair of the Fuzzy Systems Technical Committee within IEEE Computational Intelligence Society. She received her PhD of Honours in Computer Science from the Systems Research Institute from the Polish Academy of Science in Warsaw, Poland in 2010. In 2011, she was a postdoctoral fellow with the Department of Electrical and Computer Engineering at the University of Missouri in Columbia in the USA. Anna is an alumnus of the Stanford University Top 500 Innovators Science Management Commercialization Program. So with that, Anna, I'm handing over to you. Thank you.
Thank you, Mart, for your nice introduction. And today I would like to share with you my work on, or questions about understanding the data, building the bridge between the meaning of data and human understanding. And first, I would like to set the context for this presentation. Then I will introduce linguistic summarization, what it is. Perhaps some of you know this topic and this concept. For some, it may be a new concept. Then I will talk about some applications, also commercial or industry applications that we have done. And next, I will show how explanations or how can we explain data with linguistic summaries. And then, of course, at the end, I will finish with some concluding remarks. So starting with the beginning, we are talking about understandability, but understandability can have different flavors, because when we are talking in machine learning about understandability, we can talk about interpretability, we can talk about transparency, and recently we talk more and more about explainability. And even all those three terms, they correspond to understandability. They have a slightly different meaning. So interpretability for me is the ability to assign meaning to the model elements. We can interpret that certain, for instance, features, certain variables are more important than the other ones. Transparency means actually addresses the understanding of the reasoning mechanism of the model. And explainability concerns whether a model is able to offer some explanation. It can be ad hoc or post hoc explanation regarding the recommendation that is being made. And taking into this account, we should also acknowledge that currently more and more data are being collected. So, for instance, in the healthcare sector, if we consider hospitals, the number of data that are being collected is doubling every 2 years. So we are facing this exponential growth of data. Now sensor technology is becoming cheaper, and this is not only in factories. We can talk about smart industry or industry 4.0. or even 5.0, we can talk about smart houses, but we can also talk about embedded people. So the number of data is growing exponentially. And we as the people have problems with understanding this speed of growth that we are facing. So let me show you one simple example. Let's imagine a big national football stadium like Wembley or Amsterdam Arena, and let's assume that the stadium is watertight. So now let's imagine we have the magical pipe, and in the first minute we deposit 1 drop of water in the stadium. And from now on, every minute we will double the amount of water that we are at. So in the second minute we add 2 drops, in the third minute we add 4 drops, in the fourth minute we add 8 drops, and so on. And now I have a question for you. So how long it will take to completely fill the stadium? Is it hours? Is it days? Is it weeks? Or is it months? And now you should, so I see that Mart opened the poll. So can you please take a minute to vote in the poll? And I hope you had time to make up your mind. So if we can close the poll now. And can I see the results sharing?
Can you see the result, Anna?
No, I cannot see the results. Can you see my?
It's displaying now for the audience, so I'll just quickly just put it in the chat for you as well.
Okay. So I see we have quite equal results. There is no clear winner. Minutes, 13% of you voted, hours 19%, days 9%, and months 19% of you. And the answer is that it will take only 49 minutes. So if we look at some data, so it takes 6 minutes to fill a thimble, 14 minutes to fill the paper cup. After 21 minutes, a bucket will be full. After 36 minutes, we would fill the Olympic Stadium, so 50 meters long. And after 49 minutes, the stadium is full. If we still continue with this experiment, after 85 minutes, we would cover the volume of all world's oceans. And then just 10 minutes later, we would have the volume of Earth. And 3.5 hours later, so after 300 minutes, we would reach the volume of known universe. And exponential growth can go quickly crazy, because this is how the data, and this is the same speed as the data accumulates. Therefore, there is really a big challenge in dealing with the data flood. And of course, computers they help us dealing with this, and many black box models they proved to have a good performance capacity, but actually, can we understand how the decisions are being made? So here in the slides we can see some feature visualizations for convolutional nets that are being trained. And of course, we can talk about the trade-off explainability versus predictive accuracy, and the models that have high predictive accuracy, they are not very explainable, and transparent explainable models, they don't guarantee the high prediction accuracy. There is one more aspect that we should be careful, namely the difference between correlation and causation. For us, this may be something obvious, but for many people, especially not trained technically, they have problems with this. And here is a small example. As we can see, there is a very high correlation between number of people who drown by falling into a pool and number of movies that Nicolas Cage appeared in. So if we want to solve the problem of people drowning in a pool, then actually we should forbid Nicolas Cage performing in the movies. Problem solved. No, because this plot just shows the correlation relationship, not a causation relationship. And therefore, we never know based on what kind of patterns the models are using to reach their decision. Therefore, understanding of the models is really important. If we look at the maturity levels of business intelligence, so more business side, we can divide the techniques into 4 different levels. Descriptive analytics is the simplest one. It describes what happened. Diagnostic can answer the question why things happened. Next, we can have predictive models, what will happen next. And the last one is enabling us to optimizing what our decisions, what is the best we should do. And in the context of this talk, I'm in the descriptive analytics, so I'm focusing, okay, what happened? Can we describe the data sufficiently enough? And of course, many industries, they are using the dashboards, and they are extremely popular. They are adopted by most businesses today, but many dashboards fall short in the communicating efficiently and effectively with the users. And this is not a problem of technological deficiencies, but rather due to the poor design and actually human capabilities, because there is the tendency to put more and more information, more and more plots in the dashboards, and very easily we can create information overload, because users, they are always tempted. They think, oh, if I can see more data, I can understand more, so I can make better decisions. However, if we are looking at the OCDC numeracy level skills, we can see that actually on average 60% of people have difficulties in understanding the plot that you are seeing now on the screen. So OCDC level 2 numeracy means that people cannot compare information presented in simple tables. More than 5% of people don't have even simple level 1 numeracy, which means that if you present a simple bar chart with the popular holiday destinations, people cannot identify what is the most popular holiday destination. And so, in other words, that this shows the challenge if we want to effectively present information to the general population, to the user. We cannot go much beyond very simple bar charts, and even very simple line graphs. They may be not understood by general population. Of course, once the people are being trained, they can understand more and more. But of course, this requires training, getting experience. And the question is, if the person has to make the decision based under the stress level in a very short amount of time, whether they will still be able to reach the best decision. So, of course, there is the saying, a picture is worth 1,000 of words. But even a few years ago, when I looked at my phone, at the Samsung Health app, there was a plot. And then the plot was accompanied by the verbal description, just to inform the average general user about the most important, let's say, outcome or interpretation of the plot that is being shown. Oh, sorry for this. So, how to deal with this need of explaining or verbalizing the plots, the information? Of course, we can go with natural generation methods. They are quite popular, or we can apply linguistic summaries within fuzzy logic. And as you can imagine, I went for the second option. So I assume you know sufficiently enough about fuzzy logic that was proposed by Professor Zade in 1965. And what is the most important aspect? Everything is a matter of a degree. So when we are defining sets, in the crisp sets, in the traditional sets, an element either belongs to a set or an element doesn't belong to a set. In fuzzy sets, an element belongs to a set to a certain degree. So everything is a matter to a degree. So how this connects with the descriptive analytics? The easiest way is that we can generate linguistic summaries that were proposed by Professor Jäger in 1982 to describe the data that we have. So we can just describe the data using the terms, using natural language. And what are the linguistic summaries? They are template-based sentences of the form QRYs RP. So this is our template, where Ys are the objects. For instance, they are employees. Qs define the quantity, for instance, most, many. And P and Rs, they are features, they are variables. And in this case, R, so the qualifier, is optional. But in case of employees, it can be age, gender, salary, work experience, and so on. And then each of those features we can describe with linguistic labels. So for instance, for age, we have young, middle-aged, and old. And then if we define the meaning of words, if we define the meaning of linguistic variables, we can calculate the true value of a summary automatically. There are also some other criteria on this topic. So we have applied this technique, and I want to discuss just two examples that are used in a more, let's say, industry setting. One is collaboration with an agri-food company connecting agri and food here in the Netherlands. The other one is work from my postdoc experience working with Jim Keller, Jim Bezdek, and nurse Greg Alexander. So the first example in the agri-food domain in the Netherlands, it's quite rural country. It's famous for its intensive farming, and now farms are a big problem because the government aims at reduction of green gases. So the farmers are obviously not very happy about this. And many farms are more in the southern part of the Netherlands, where you can see on the map. And well, it takes quite some time to, let's say, to grow the animals, and animals can grow faster if they have better conditions. So what we have done, or what the company was experimenting first, they developed a dashboard, a visual dashboard, where they, well, first they installed the sensors in the barn. They had a sensor outside the barn to measure the temperature, humidity, and so on. They had a sensor inside the barn to measure also temperature, humidity, and CO2 level in the barn. And they have done this because pigs are very sensitive animals. If the weather or climate condition inside the barn is, well, not good enough, then either the animals will get sick or they will not gain the weight in the optimal speed, meaning that it will take longer till the animal is ready to be delivered to a slaughterhouse. And actually, the farmers didn't like the dashboard with only the numerical information with all those plots they could challenge. So the owners, the company representatives heard about the linguistic summaries techniques, and we had a small project when they generated the widgets and the linguistic summaries were added to the dashboard. And we tested actually whether the users, the farmers, they like this using a technology acceptance model that is looking at the perceived usefulness, ease of use, satisfaction, and intention to use. We asked questions, 14 questions with 7-point Likert scale, and actually perceived usefulness was very high. The only question that didn't score very much was in the intention of use. We asked the farmers whether they would recommend this solution to their colleagues, and here we scored the lowest solution, because farmers don't like to recommend their solutions to each other. They don't like to receive the advice. They don't like to give advice. Therefore, they are not good for marketing purposes. The second application was in the elder care during my postdoc at Mizzou. And perhaps some of you have heard the story of Jim, so the collaboration with elder care facility that aims at helping residents to stay active as long as possible, so to limit this functional decline that can be caused by certain, let's say, events, certain diseases, falls, and so on. And actually, to prevent those diseases, those adverse effects, there should be good communication between the system. They put the sensors in the patient's rooms and the caregivers. So they had some basic sensor motions installed in the bed, in the rooms, everywhere in the house. And then those sensors, they could be visualized, showing, for instance, motion sensor density maps, and then the nurses could see either a regular pattern or irregular pattern. We tried to apply linguistic summaries to those data, and then we were focusing on the nighttime sensing, because this is the time when the residents are supposed to sleep. So we focus on the motion and bedroom restlessness. And we just generated summaries of a single night. And this is data from just one resident and his history that I want to show. So he had a heart surgery. After the surgery, he was not in the room, but still the cleaning ladies were coming. Then he had a relatively stable period. Some data is missing, and then unfortunately, the patient had a stroke, and shortly after, the patient died. So for some examples of linguistic summaries for just one night, it could be most 15-minute intervals have a low level of bedroom motion, or almost all 15-minute intervals had a medium level bedroom motion, have a high level of bed restlessness. So we tested them with the nurses, and they found them quite interesting. So then we were looking whether those linguistic summaries are specific enough, because we used just three linguistic labels: low, medium, high. So can we detect bad nights for a resident? And then we calculated the prototypes. What is, can we have a method that finds what is the typical description of a single night that would happen? And then indeed, we managed to generate them based on the calculating the distances between individual summaries, clustering, and finding the prototypes. And when we had the prototypes, we could indeed detect anomalies, and this is a simple thresholding problem based on comparing the description of the last night with the prototype. And indeed, we could see for this patient there were some anomalies, some bad nights detected before the heart surgery. Then after the recovery period, it was fine, but towards the patient was getting closer to the stroke, we were receiving more and more alerts. We were receiving also some alerts earlier, so this is the matter of the proper thresholding. But still, with this very simple technique, we could capture variability. Okay, so that was one topic. And the second aspect of linguistic summaries that I would like to present to you is actually how linguistic summaries can help us in explaining what happened in the data or what happens in the model. And if we look at explanations, we can think about 6 basic types of explanations: visualizations, model simplifications, local explanations, or explanations by indicating feature relevance, explanations by example, or text explanations. And here, linguistic summaries, they belong to the category of the text explanations. And in this case, I want to discuss or to show 2 projects regarding using or applying linguistic summaries and testing their explanatory power. The first one is really testing whether linguistic summaries can serve as explanations. And what we did, we created a classification model of a simple data set, and then we generated linguistic summaries where the summarizer was the class predicted by the model for a certain point that we wanted to predict, and qualifier, so a feature that limits our data set, our trained data set that we are describing was supposed to be similar to the point that we want to describe. And Q was the best quantifier, so describing the quality quantity that meets this condition. So we did this on 2 very simple data sets, iris data set and glass data set. We generated some examples, and we had interviews with participants using 5-point Likert scale, talking about understandability, usefulness, trustworthiness, helpfulness, and confusedness. We had also some open-ended question asking the participants to share their opinion about this topic. And here are the results. So we can say that the people were generally quite positive to this. So they could very easily understand the results, but also they could trust them, they find them helpful and useful, and they were not finding them very confusing. Of course, that was the relatively small sample of users, and we want to apply this to industry setting. So this is a project with a big car manufacturing company where we are working on currently on building a good classification model that we can explain with linguistic summaries. So once we have the results, please stay alert, because we will be publishing about them. And then the second type of explanations with linguistic summaries we did, it was in business process, in domain of business processes, and here we were focusing on anomaly detection and anomaly explanations. Why? Because even though organizations, they try to optimize the work by introducing structured business processes, recommended way of working, many organizations deal with flexible processes with high workload, change in rules, some anomalies, special cases which cause deviations for those in those business processes. And if we look at the state of the art in anomaly detection, there are really, I would say, around 100 of different anomaly detection algorithms. We can detect them based on different methods, different techniques. So there is quite a lot of work done. But then what we receive just indication this is anomaly. And the question is this information useful to the users? Actually, not. So we proposed a method that can explain why this case is an anomaly. So first we need to isolate those anomalies. We take anomaly one by one. We find similar cases to this anomaly. We will find the differences between similar normal cases where there are some activities in the process where skipped or some activities were deleted, whether there was a replacement. We have some protoforms defined, some templates for the linguistic summaries, and then we are defining the summary. So here I would like to show just one example. So this is an example of a process for handling the appeals by a municipality. And we see that the process starts with registering appeal, and then either it can be sent to a different unit, or if it is accepted, then confirmation is being sent, and then either it is rejected, and then a draft advice is written, or some documents may be received, or there is a revision, or always a person can withdraw the appeal. But once the documents are being registered, there is a hearing and written advice, and then advice is being sent, dossier is being created, and decision is processed, and all those processes ends with the appeal being archived. And we have here one case. So we have a sequence: create dossier, process decision, register appeal, confirm reception, rejected, write draft advice, send advice, archive. And what we see is that the activities create dossier, process decision, they are, which should be actually later in the process, they are happening quite early. And anomaly detection method says this case is anomalous, but our method is able to say that no highly similar normal cases have activities, create dossier, process decision performed before a register appeal. Now, or actually that those activities are missing at the end of the process. So this is, and we believe that there is high potential in following this this research. Unfortunately, here the PhD student that was working on this was would and stopped his PhD and is now working in a company. So now I guess it's time for some concluding remarks, and here I would like to share that I hope I managed to convince you that linguistic summaries is quite a simple yet powerful tool that can automatically describe the data, can be provide understandable results for non-technically trained users, and it has some potential for explanations, but of course future work is needed. But of course, when we are talking about understanding the data and closing the gap between meaning of data and human understanding, there are those three different types of understandability, and we should be careful which one we want to approach. So thank you. This is all that I prepared for today. So are there any questions?
Thank you very much, Anna. One of the questions from the audience is, thank you for your presentation. Could you recommend for us a reference to clearly understand the differences between transparency, interpretability, and explainability?
Yes, there is. I will stop sharing my screen. Yes, there was a reference. Let me find it. I just need to find the proper.
Yeah, that's all good.
Yeah. So
just while Anna is finding the reference, just remember, if you do have any questions, you can type it in the questions box.
Actually, I like this paper. Perhaps I will put this in the where can I send organizers
Yes,
and panelists?
you can either put it in the chat for everyone, or you can send it to me, and then I'll send it through the answer for the question.
So I put this to organizers and panelists because this is the option that I had. So
Okay.
this is the paper that I like, that introduced those three concepts quite nicely. It's the mythos of model interpretability. It's a relatively old paper from 2016.
Okay, so I've sent that through to everyone.
Okay.
Yes, just a further question. So thank you for your presentation. First, I hope to receive your reply on my email sent to you under the title New Achievements in Fuzzy Systems. Then the question is, what is the relation between explainability and accuracy in your view?
Well, so explainability and accuracy, they concern two different topics, and actually I will, so definitely the model is better interpretable the smaller accuracy it has. So, but how is it with explainability? Well, the more accurate models are generally more complex model. However, here we are coming to another trade-off between variance and bias. So two complex models can be too specific for the data. They can just they cannot generalize correctly. Explanations of more complex models can perhaps be more complex. So then there is a question: can we capture the right? Let's say, are we capturing the right patterns? But it is very interesting topic to discuss the relation between explainability and accuracy. And I can disclose to you that from February we will be starting with a master project working on this relation, looking at the price of explainability and seeing whether a simpler model what is the loss in the accuracy or the performance quality of such a model, and compared to a more complex model that is more difficult to let's say to explain to the user. So still, I'm quite, I cannot give a right answer right now, but my intuition tells me that more complex models, they are more difficult to explain.
Right, thank you. Then I was just also wondering, with your approach, you also said that the first step will be to then be able to have the anomaly, and then from there you go into describing more information.
Yeah.
But you also said that there are many approaches to find the anomaly. So which ones of those would you actually recommend for someone who may not know the field that well, but want to try it out and see how it works?
When we did a small comparison study, literature study, actually deep learning methods were working the best, and they were able to detect all kinds of process anomalies or anomalies in the event logs. So definitely the most powerful black box model, they were working the best. However, with certain types of anomalies, even the simple, say, thresholding methods, which are quite interpretable, they were able to detect well enough the anomalies. So all it depended what type of anomalies we would like to detect. Is it anomaly in the sequence of the activities, or is it the anomaly in time taken by the activities or resource that is performed or certain other features? But if we want to have them all without putting so much the expert knowledge, unfortunately, and I'm saying this with sad so the deep learning model was the best. You are muted, sorry.
Thank you. Also, with regards to adding the descriptive linguistics to the work that you're currently doing, what have you found as being the greatest challenges, and why, and what did you do to solve them?
I think so. The user studies they are quite difficult. So to understand the user needs, and so first is understanding well the user needs, and finding the right tool for addressing those user needs. Because even though let's say I'm working on linguistic summaries for a long time, it's not the only type of research that I'm doing. So some projects they require different needs, and then in this type it's actually um, the user evaluation going this one step further, having the users filling the evaluations, but also users defining, putting into the fuzzy sets definition the meanings that they have in the words. So everyone knows what warm temperature is, or a warm nice day. But if I ask to talk to give me some boundaries, then people have quite some difficulties with this, even though I want to know only more or less because of this fuzzy concept, fuzzy set concept that I'm using, let's say also degrees. I think it requires certain trust from the user and certain approach that they can accept this. Regarding future directions, I believe in huge potential in explainability, but this is still ongoing work, and if we can provide more understandable explanations, because I asked people about the currently now the standards Lime and Shap. If you talk honestly after a few beers or wines with people with non-technical experts or domain experts that use those methods, they actually don't like them, but they are too afraid to say that loudly, because otherwise people can think, oh, they are stupid, they don't understand this. But they find, well, I heard too many opinions that Lime and Shap, they are not very user-friendly, and they require understanding how to interpret the results.
Yeah, thank you. That would have been my next question, so thank you for answering that. We have also just in the comments people that are saying thank you a lot for the talk, and also thank you for answering their questions. And then we have another question from David. Thank you for the presentation. I wanted to ask your expert opinion on achieving explainability in deep learning, moving from the black box to a transparent box. What do you think are the promising paths to achieving this? Second, is it possible for the slides of the presentation to be shared? Yeah, so David, with regards to the slides, you should be able to see that in the handouts panel. So you should be able to download that. But for the other part of the question, Anna, if you can please answer that. Thank you.
So the question is how to make shift the let's say the deep learning into white or at least gray box models. I don't have the clear answer yet, but if we think, for instance, that shallow neural networks, they had the same explanatory power or the same predictive power could be replaced by fuzzy inference systems that are considered gray box models, then perhaps if we have the replace the deep neural learning, deep neural nets with deep fuzzy inference systems, or a certain hierarchy of the systems, interpretable systems, then perhaps we will be opening the black box of deep learning. So this is my assumption, but unfortunately, deep learning is not in, let's say, my research interests. So this is always on the side of my work.
Great, thank you, Anna. Then I'm just going to wait just a few seconds to see if any last questions are coming in. Okay, it seems like those were then the questions people really wanted to get answered today. I'm sure that they can also get into contact with you if they have any questions later about what you discussed today.
Yes, of course. So please feel free to send me an email. I try to answer to all of them in a reasonable amount of time. You know, sometimes we have busy periods, and then you can wait a week or so.
Yeah. So there's also a question from Sandeep whether you can collaborate on deep learning things, because he's if you're interested in that. So I'll just forward you also his email that you have posted here.
We can always discuss the potential collaborations. Why not?
Great. With that, I would like to thank Anna. Thank you so much for making the time and also for giving the great talk today. I'm sure that everyone here has learned a lot about the topic. And I also would like to thank all of the people in the audience for also coming and attending the event. So with that, I hope that all of you have a lovely day wherever you are in the world, whether it's the morning or the evening. And we hope to see you also in our future webinars. Thank you very much. Bye, everyone.
Thank you. Bye.